Hello guys, welcome to today's video in which we will go over the net present value concept and how to do it in Excel. So I will basically focus on the theoretical part of NPV, which is the net present value. So first we're going to talk about what is the net present value, what is the time value of money, and what are the factors affecting the net present value. Then we're going to do an example where we solve the net present value without an initial investment on Excel using two different approaches. Third, we will go over the net present value, however, this time with an investment requirement. And finally, what are the pitfalls or what to pay attention for whenever you're solving the net present value on Excel. So first, we're going to be discussing the theoretical part of the net present value. Well, before we get into the definition of the term, you need to understand that whenever you're dealing with anything that is related to the future, it's better to draw a timeline. So let's say we have the following timeline where we have 3 to 4 years of future data. And imagine that you expect to get $10 in year 1, $20 in year 2, $30 in year 3, and $40 in year 4. Now the question is, what is the value of those future cash flows today? So the net present value is a technique where we try to find the value of future cash flows today. And when we say today, we're talking about time zero. The second definition for the net present value is related to the process of capital budgeting, in which we're trying to see if the project is profitable or not, and what is the level of profit that we expect out of investing a certain amount right now. So this is basically a negative amount compared to what we are expecting to get in the future based on the present value of the cash flows that we see. And we're gonna work on an example that is related to the concept later on in the video. It is important to go over the concept of time value of money. So if I ask you, would you rather get $10 right now or $10 1 year from now? Which one would you prefer? Logically speaking, people would say, I would rather get $10 right now because I can try my best to make it more than $10 in a year from now. This is why whenever we compare $10 right now to $10 1 year ahead, we would rather get the $10 right now, and we say that the $10 in the next year is actually worth less than $10. So if I want to know the value of a future cash flow right now, it should be less than what is shown on the timeline. So when we talk about the net present value, we are talking, number one, about a discounting approach. Why? Because the technique in which we try to find the value right now of a future cash flow is called discounting. We are discounting future cash flows to find their value today. And two, whenever we are discounting, we take into consideration what we call the discount rate. Well, what's the discount rate? The discount rate can be your cost of capital. It is what we call the opportunity cost, right? It is what we call the opportunity cost. And this is why you would rather have the $10 right now so that you can make it more than $10 in the future, i.e. $10 right now at time zero should be more than the $10 that we have 1 year ahead because of the concept of the discount rate. And if we want to know the value of the $10 that we expect to get 1 year from now, we should discount it, i.e. we divide the $10 by 1 plus the discount rate, which is a percentage, to the power of the period. And since we're talking about year 1, thus it's going to be to the power 1. So this is when it comes to the theoretical part of the net present value. Now we can move on to Excel to look at a couple of examples. In the first example, we have a series of future cash flows from year 1 up until year 5, where we expect to get $50,000 in year 1, $65,000 in year 2, $70,000 in year 3, same goes for year 4, and $75,000 for year 5. And we are asked to find the net present value with a discount rate of 10%. So what we have is the following. We have a timeline of 0, 1, 2, 3, 4, and 5. Those cash flows are the future cash flows in our what? In our timeline. What we want to do is we want to know the value of those cash flows right now, right now, right now. So the first way I'm going to approach it is using method 2 because it's a manual way. So what do? We're saying that those are future cash flows. And to find the value of future cash flows right now, we should discount by the discount rate so that we can know the value of those cash flows today at time 0. To do that, what we do is, as we said, we divide the future cash flow by 1 plus the discount rate that we have, and we fix it for the sake of financial modeling, and then we raise it to the power of the term that we have over here. This way, if we drag the formula, the term of the cash flow will be also dragged with the formula itself. And we do that to the remaining years, and then we say, well, the net present value is equal to the summation of the discounted values, and it's equal to 246,000. Now, there's another way, which is an easier way, where you can do it using a formula, in which we will write equal NPV, and then we open parentheses. The rate is the discount rate, and the value are the future cash flows. Look at what the formula says. Value 1, value 2, value 3. So it always assumes that the first value that you're going to put in the formula is the first year for the cash flow, is the first cash flow for the first future year. So we will select all the values, and then we press enter. And as you can see, we have the same answers. Now, in the next example, what we're going to see is another requirement where we have an initial investment to be paid right now. So what we're saying is the following. Now is split into 2 parts. Is split into a part where I have to pay and a part where I have to know the value of the future cash flows. What I have to pay is being paid right now. So no discounting, because I discount to find the value right now, but the investment requirement is already given right now. So no discounting for this part. As for the second part, we will do it as we did it before. However, you need to pay attention that a lot of people tend to include the negative cash flow in the NPV formula. This should not be done, because if you do it, it will assume that this cash flow will be a requirement for next year. As you remember, the formula starts with value 1, value 2. However, this value is value 0, so we do not include it in the formula. Let's look at the way we should approach it. So as usual, we will start with what? With method 2. As we said, the discounted cash flow for the initial requirement will be the same because we need to pay it right now. So we need to compare apples to apples, right now with right now. This is the right now for the negative side, and those are the values that I should discount to get a right now values so that I can say I have an apple to apple comparison. So I'll do the same. I'll divide the 50,000 with 1 plus the discount rate. I'll fix the discount rate, raise it to the power of the term itself, and then drag the formula. So we can say that the net present value is equal to the summation of all the values that I have, which is 96,000. Now, using the method 1, we need to pay attention not to include the initial investment requirement in the formula. So what we will do is we say that the NPV for all the values that we have on top is, we're going to put the negative cash flow as it is, and then we're going to say plus NPV, and we find the NPV just like we have done it earlier. And technically speaking, we should have the same answers. Now, as for the pitfalls, number 1, never ever include the negative investment requirement if it is given that it is happening right now. So if you are required to pay right now, you don't include it in the formula. Instead, you add it with the answer of the NPV. So we could have done it this way. We can say that this is the requirement, and then we find the NPV over here based on the rate, and then based on the values. And then the total answer would simply be the summation of both. Okay? Or we can just do it in a single line. Number 2, you need to pay attention to the cash flows. And you need to know that the further we go to the right, the less the value will be. For example, if we have 1, 2, 3, and 4, and we have 10,000 all over, if we try to discount the values of the 10,000, we're going to see that the more we go to the right, the less the value will be. Why is that? Well, because the formula say we're dividing the value of the cash flow by 1 plus the rate to the power n, and n resembles the period. So the larger the n, the more the denominator, and the more the denominator, the less the answer. This is it for this video. I hope that you have enjoyed. If you have any question, please drop it in the comment section. If not, I'd appreciate it if you give me the thumbs up button and subscribe in the channel to stay notified of any videos coming soon. Thank you guys.